Right, this lesson's on average velocity. By the end, you'll be able to define velocity and distinguish it from speed, and also calculate average velocity from displacement and elapsed time. So to review what we were talking about before, imagine I'm playing fetch with my dog, and we start at the 0 mark, which we'll call the origin, and I throw the ball, and he runs out to the 10-meter mark. So we could say that he has traveled a distance of 10 meters. We can also say that his displacement, the change in his position from the start, is 10 meters, and because displacement is a vector, it's, let's say, 10 meters to the right. Now, if he turns around and he runs back to the 5-meter mark, although he's traveled now 15 meters, his displacement is only 5 meters because it's the change in his position, and if we're counting from the start when he's at 0, he's gone 5 meters to the right. So that's, again, just a review of the difference between distance and displacement. Now, speed is the rate of change, or how fast distance is changing, whereas velocity is how fast position is changing. We can also call that the rate of change. I'll write ROC in short, the rate of change of position. And because position has a direction, just like displacement had a direction, velocity will also have a direction. So we're going to put that little arrow on top to indicate that it has direction, that it's a vector, and we use v for velocity. And because displacement and position were in meters, and our time is in seconds, the units of this are going to be in meters per second, which you'll sometimes also see written like this with a negative exponent. So average velocity is the change in position. Remember, that's also called the displacement. So this is the displacement divided by the time. And we're going to use the delta to signify change in time as well. Remember from previously that the displacement is equal to position 2, or the final position, minus position 1. That's what the delta means, the difference. And similarly, this is time 2 minus time 1. Okay, let's look at an example. We've got a baseball situation. Ball's being thrown from third base to first base. That's about 38 meters, and the field's oriented, so that throw is west, and it does that in 1.5 seconds. Find the average velocity over the time interval. So the average velocity, which we'll write like that, the subscript meaning average, is equal to the displacement, or the change in position, those are the same things, divided by the time. The change in position, or the displacement, is 38 meters west. And the time that it does that is 1.5 seconds. And so we divide those two we divide 38 by 1.5, and we get 25.3, and that repeats. So I'm going to call that, for now, 25.3 meters per second, and we need to include the direction in our answer as well. Okay, so there's a simple calculation where you're actually given the displacement. Sometimes you'll have to work out the displacement by subtracting one position from another. Okay, here's another example. A cyclist rides 1,000 meters north, then turns around and travels back to where they started. The round trip takes 360 seconds. Find their average velocity over that time interval. So before we get too far in this, just notice what's happening. This person is going from the start. They're going 1,000 meters north, and then they are turning around and coming right back to where they started. Now remember that their displacement, which is their final position, minus their initial position. And in this case, these two are exactly the same. And so their displacement is equal to 0. And therefore, their average velocity, which is their displacement divided by the time in which that displacement happened, is also equal to 0. So here's an example where average velocity can be very different from average speed. So just keep that in mind. Now, if we wanted their average velocity from here to this time, then that would be very different. We would take our 1,000 meters north and divide by, let's say that took 180 seconds. Then we would divide our 1,000 meters by 180 seconds, and we'd get that answer as our average velocity for just the first part. But if we're asking for the average velocity for the whole thing, we need the displacement for the whole thing, and in this case, that's 0. By the way, notice that if the question was what's their average speed, the average speed, remember, is equal to their distance divided by the time. The total distance is 2,000 meters, no direction, there's no direction with speed, divided by 360 seconds, and that gives you 5.5 repeat, or let's call that 5.6 meters per second. So again, a difference between their average speed and their average velocity. Okay, so just to review, speed is how fast distance is changing. Whereas velocity is how fast position is changing. And it's going to have a direction, whereas speed doesn't have a direction. As we've just seen, average velocity can be very different from average speed, and that's going to happen in situations like the one we just described, where an object changes direction during the time interval. We're often more interested in instantaneous velocity, though, and that's actually a little easier, because the instantaneous velocity will always have the same magnitude. That's another way of saying the same size or the same number as the instantaneous speed. It just adds direction to it. So if my dog is running in this direction at 5 meters per second, and that's the reading that if I could put a speedometer on him, that's the reading that the speedometer would show. That's the instantaneous speed. All we have to do is add a direction to that, and that's the instantaneous velocity. So that's actually a bit less confusing. Those two numbers will always be the same. You won't run into the issues we had above. Okay, and that's an introduction to velocity.